locate the centroids of the following area, and we have to refer the given figure, that is this radius is given as 30 mm and we have the radius of this quadrant as 30 mm. See, in this figure they have given you a semicircle and also a quadrant, but we need to determine the centroid of the area which is shaded. Now, to determine the centroid of this particular figure, you need to consider this part also, but what about this component? It is not a triangle because it is having a smooth edge. So, we need to consider this as a rectangle or a square depending on the dimensions, and then try to remove this area as this looks like a quadrant. It will be a quadrant. I repeat, this shape whatever you are seeing is not triangle, as this edge is smooth. Hence, you need to consider a square or a rectangle depending on the dimensions, and then try to deduct the area of quadrant. See, this looks like a square. It is a square. So, in square, if you remove this quadrant, we will be able to locate its centroid easily. Okay, you have to be very careful with respect to problems of this kind. Okay. Okay. We shall divide this into known components. Before that, what are the steps involved? Do you have any axis of symmetry? No. We can write the reference axis. It is already given. So, this will be the reference axis which is already given. Okay. And then we need to locate its x bar and y bar values. Okay. Now, we shall divide this into component 1 and this square be component 2, this quadrant be component 3, which has to be removed out. Okay. So, let me start. Component 1 of radius 30 mm, this will also be equal to 30 mm. It is also a quadrant, it is also a quadrant. So, you need to consider component 1 as the quadrant of radius 30 mm, and second component will be the square of size 30 by 30, and the third component be quadrant of radius 30 mm. Okay. So, this is not a semicircle, it is a quadrant of a circle. Please be careful. So, quadrant of a circle, and I have written the radius as 30 mm and 30 mm because it is given. Now, let me write its area. A1 is equal to pi into 30 square divided by 4. Okay. This is in mm square. Now, try to locate its centroid, all the x and y components. So, x and y components of a quadrant can be located at this point where the x and y components will be equal to what? 4r by 3 pi. So, x is equal to 4 into 30 by 3 pi mm, and also its y is equal to 4 into 30 by 3 pi mm. Okay. This is the x and y components of individual component, that is component 1. Now, component 2. Component 2 is a square of size 30 mm by 30 mm. So, where does the centroid of this square lie? Exactly at center. So, its x and y components can be marked like this, x and y. So, writing its area, A1 is equal to 30 into 30. Should we write minus sign for component 2, A2? Are we removing square? No, it shall be positive itself. Its x is equal to 30 by 2 and its y is equal to 30 by 2, 15 mm. Component 3. So, component 3 is again a quadrant. mm and 30 mm. So, where can we locate the centroid of this quadrant? At this point, and this will be equal to its x component and this will be equal to its y component. Now, coming to its area, A3 is equal to pi into 30 square by 4 with a minus sign, because it is the part to be removed, minus sign, and its x component 4 into 30 by 3 pi and its y component 4 into 30 by 3 pi. See, the components of x and y is measured with respect to what I have written in the diagram, but if you want to measure this distance from the other end, it should be 30 minus 4r by 3 pi. See, if you want to locate the distance from this end, it should be 30 minus x. Similarly, if you want to locate it from this end, it should be equal to 30 minus y, which is nothing but 4r by 3 pi. Okay? So, we shall see if this is required in the next step. Clear? So, if this is okay, let us write the table. X bar from OY, Y bar from OX, area in mm square and units of X bar and Y bar in mm. So, component 1 is a quadrant, area is pi into 30 square by 4 mm square, and its x component with respect to the given axis, that is, we know it has to be located at some point. This point was determined based on this step, and try to measure it with respect to the OY axis, which is x1. Similarly, measure its y1, which is nothing but 4r by 3 pi and 4r by 3 pi. So, x1 is equal to 4 into 30 by 3 pi, and also y1 is equal to 4 into 30 by 3 pi. Now coming to second component, it is a square of size 30 by 30, area will be equal to 30 into 30, its x2 will be equal to 15, y2 will be equal to 15, but be careful with the signs. Now this is a square, we need to locate its centroid, okay. Measure it with respect to reference axis OY. Now see, we are measuring towards left. So x, if it is measured towards left, the sign convention will be minus. So x2 should be written with a minus sign. It is minus x2 is equal to minus 15, whereas y2 is measured with respect to OX, it is upwards, so it is positive itself. Y2 is plus 15. Second component is over. Third component, again it is a quadrant of radius 30 mm and its area should be written with a minus sign, which is minus pi into 30 square by 4. Its x3 is equal to, see, we tried to locate the centroid of this individual component at some point here, but it has to be measured with respect to this axis, which is called as x3. See, we tried to locate it from this end, that is from this end it was equal to 4r by 3 pi, but we need to measure with respect to this end, that is OY axis, that will be equal to 30 minus 4r by 3 pi, equal to 30 minus 4 into 30 by 3 pi. Coming to its y3 component. So the same point should be measured with respect to OX axis, which is y3. We had tried to locate it with respect to this end. See, here it is y. So if this is y, I need to measure it from this end, it would be equal to 30 minus y, the same thing, that is equal to 30 minus 4 into 30 by 3 pi. But we have missed out something, that is the x3 value should be written with a minus sign because we are measuring it towards left. So this x3 is equal to minus of 30 minus 4r by 3 pi because it is measured towards left. Please be careful. Okay. So now in the formulas of x bar and y bar, x bar is equal to a1 x1 plus a2 x2 plus a3 x3 whole divided by a1 plus a2 plus a3, which is equal to a1 is pi into 30 square by 4 into 4 into 30 by 3 pi plus a2 is 30 into 30 into x2 is minus 15 plus x3 plus a3 minus 30 into pi square by 4 into x3 minus 30 minus 4 into 30 by 3 pi bracket close. This is a3 into minus x3. Sorry, x3. x3 is nothing but minus 30 minus 4r by 3 pi whole divided by A1 is pi into 30 square by 4 plus 30 into 30 plus minus of pi into 30 square by 4. After substituting the A1, X1, A2, X2, A3, X3 in X bar formula and substituting the values, we get X bar is equal to 8.56 mm. X bar is equal to 8.56 mm. Similarly, we shall calculate the Y bar. So, Y bar is equal to A1 Y1 plus A2 Y2 plus A3 Y3 whole divided by A1 plus A2 plus A3, which is equal to A1 is pi into 30 square by 4 into its Y1 is 4 into 30 by 3 pi plus A2 is 30 into 30 into Y2 is 15 plus minus 30 square by 4 into Y3 is 30 minus 4r by 3 pi whole divided by pi into 30 square by 4 plus 30 into 30 plus minus of pi into 30 square by 4. So, after calculating this, we get Y bar is equal to 11.44 mm. Therefore, G of X bar comma Y bar is equal to 8.56 comma 11.44 mm. So, these are the coordinates of the centroid G. So, X is 8.56 and Y is 11.44. So, somewhere at this point, say at this point, this is G of X bar comma Y bar. This will be our XX and YY, 8.56 and 11.44. This is how you locate the centroidal values in the diagram. Okay. See, again in this problem we have a quadrant and one more quadrant here, but the shape which they have shaded is an uneven shape, not a regular geometrical figure. Hence, you need to divide this into known components. That is, now we are dividing this to a quadrant. Then coming to this portion, we cannot determine the center of this portion. That is why we need to consider it as a square and then remove the quadrant. Then only you will be able to locate its centroid. Okay. So, these are the steps involved in it. After naming the components as component 1, 2 and 3 and locating the individual components of component 1, 2 and 3, and then try to measure those individual components with respect to the given axis or the reference axis, that is with respect to OX and OY axis, and then try to write those values in the table and then substitute that in X bar and Y bar formulas. Okay. That will give you the coordinates of centroid, that is X bar and Y bar, and then locate the same in the figure at the last step. Clear? Okay then. let us move on to the next problem, which is locate the centroid of the area shown in figure So, need to locate the center of the area which is as shown in figure. So, figure goes like this. This is 4 mm, this is 6 mm, this is 3 mm. This is 6 mm and the radius of this quadrant is given as 3 mm, and hence we can write this distance also equal to 3 mm. Now, this is the figure given. You can easily understand that this region is the shaded region and this region is the part that has to be removed out. Okay. So, this is the actual lamina, but we need to remove these components from it. That is, we need to locate the center of this particular lamina which has openings of this kind. So, for that what we shall do? We shall follow the same steps as we did in the previous problems. That is, we need to divide this into known components whose centroidal values are known, and then try to locate the center of individual components and then measure it with respect to the coordinate axis OX and OY. Okay. Before that, do you have any axis of symmetry in this problem? No. So, we shall go with the next step, that is naming the axis or the coordinate axis. Let this be point O, OX and OY is already given. The next step will be dividing this. So, if you observe this part, this can be named as a rectangle. Okay. So, let me name A, B, C, O as a rectangle and component number 1. Next, let me take this triangle as component 2. Okay. Then let me take this quadrant as component 3 and this portion has to be removed out, and also let me take this as component 4 which is a semicircle which also has to be removed out. So, component 3 and 4 has to be removed out, component 1 and 2 should be considered. So, we need to locate the centroid of this particular lamina after removing component 3 and 4. So, in this figure or for semicircle the radius is not given, instead the diameter is given as 4 mm. You can easily write the radius as half of diameter. Okay. Now, the axis is given. The next step will be writing the individual components and writing the individual areas and its x and y components. Okay. So, component 1. What is component 1? A rectangle of size 10 mm by 9 mm. So, let me complete the namings. So, let this be D, E, F, and let me not use G because it is used to denote the centroid. So, let me write this as H and this point as I. So, component 1 is ABCO. ABCO. So, where do you locate the center of a rectangle? Center, and try to measure its individual x and y. Okay. So, A1 will be equal to 10 into 9 mm square, x is equal to 10 by 2 is equal to 5 mm, y is equal to 9 by 2 is equal to 4.5 mm. This is component 1. Similarly, we shall write component 2. Component 2 is triangle EDB. This is 6 mm and this is 3 mm. So, where does the center of this triangle lie? So, this is at this point, and this will be its x component and this will be its y component. Now, coming to its area, A2 is equal to half into 3 into 6 mm square. Now, x is equal to 3 by 3, 1 mm, and y is equal to 6 by 3, which is equal to 2 mm. And next component 3, which is a quadrant, and its radius is 3 mm. E, C and F. Where does the centroid of this quadrant lie? At this point, and it is measured from this point, which is x, and this is its y. Now, writing its area, A3 is equal to minus pi into 3 square by 4 mm square. Why minus? Because it is the part to be removed. And then its x component 4 into 3 by 3 pi, which is 4 by pi mm, and its y is equal to 4 into 3 by 3 pi, which is equal to 4 by pi mm. Okay. Next, at last, component 4. So, component 4 is a semicircle and this diameter is given as 4 mm. We can write the radius as 2 mm and 2 mm. A, H, I. So, the area of this A4 is equal to minus pi into 2 square by 2, pi r square by 2 mm square, and its x and y components can be located here. Y component, which you know, which is 4r by 3 pi. You cannot write x. Okay. So, these are the details of component 1, 2, 3 and 4. So, using this, let us try to write the same in the tabular form, but let us measure the same components x and y with respect to the referral axis or the coordinate axis. Okay. Component area x bar in mm with respect to OY axis, y bar in mm with respect to OX axis. Component 1 A, B, C and O are rectangle. Its area is 10 by 9 mm square and its x1 is equal to. So, we tried to locate the centroid of the individual component that has to be measured with respect to the referral axis. So, this will be x1, this will be y1. So, x1 is equal to 10 by 2 5 mm, y1 is equal to 9 by 2 is equal to 4.5 mm. Component 2 triangle BDE, area is half into 3 into 6, its x2 is equal to, we know the center of this triangle lies here, but we need to measure it with respect to this line or axis. This is our x2. So, that will be equal to 4 plus 6, 10, 10 plus 3 by 3. mm, y2 is equal to, for the same point measure it with respect to OX axis, this will be y2, but we had tried to locate this particular distance. So, what you can do is you can take the total distance, then deduct this distance, or if you know this distance, so here from here to here it is 3 mm. So, if this is h by 3, this will be 2h by 3. So, whatever is easier to you, please follow that. Okay. So, if the total height is 9 mm, I shall deduct this, it will be easier, that is equal to y2 is equal to 6 plus 3 9 minus h by 3 is 6 by 3, which is equal to 2, 9 minus 2 is 7 mm. Next, component 3. Component 3 is a quadrant FEO and the radius is 3 mm. Its area should be written with minus sign pi into 3 square by 4 and its x3 shall be equal to. So, we know the center of this lies here. So, measure it with respect to OY axis, this will be x3. So, again for this, if you know the total distance from O to C, which is 10 minus 4r by 3 pi, which is known to you, that is equal to 10 minus 4 into 3 by 3 pi. This is the value of x3. Similarly, y3. y3 should be measured with respect to this axis. This is y3, which is nothing but 4r by 3 pi. Last component 4, which is a semicircle AHI. So its area is again minus pi into 2 square by 2, and then its x4. See, we know the centroid lies somewhere here for a semicircle. So this distance is nothing but equal to radius, that is nothing but x4. x4 is equal to the radius 2 mm, and y4 is equal to, measure it with respect to OX. So the same distance but measured with respect to OX axis. This is y4. So you know the total distance is 9 mm. 9 mm minus 4r by 3 pi will give you the exact y4. So 9 minus 4 into r is 2 by 3 pi. So these are the values of x1, y1, x2, y2, x3, y3 and x4, y4 along with its areas a1, a2, a3, a4. The areas a3 and a4 should be written with a minus sign because it is removed out. Okay? So now let us substitute this in the formulas of x bar and y bar and calculate what is x bar and y bar. So a1 is 10 into 9 into x1 is 5 plus a2 is half into 3 into 6 into x2 is 11 plus a3 minus pi into 3 square by 4 into x3. x3 is 10 minus 4 into 3 by 3 pi plus a4 minus pi into 2 square by 2 into x4 is 4 by 2, 2 whole divided by 10 into 9 plus half into 3 into 6 plus minus pi into 3 square by 4 plus minus pi into 2 square by 2. So on substituting we get x bar is equal to 5.54 mm. Similarly, on substituting the values of y1, y2, y3, y4, we get y bar is equal to 4.761. Okay. So if you have doubt how this 4.761 was obtained, let me change this x values to y's, then we will be able to calculate it easily. So what is y1? y1 is nothing but half of 9, 4.5. What is y2? y2 is 9 minus 6 by 3 is 7, and x3 is 9 minus 4r by 3 pi, sorry, it is 10 minus 4 into 3 by 3 pi, and at last y4 is 9 minus 4r by 3 pi, 9 minus 4 into 2 by 3 pi. So, if you substitute the values of y1, y2, y3, y4, then you will be getting y bar equals to 4.761. Therefore, at last g of x bar comma y bar is equal to 5.54 comma 4.76 mm. Now, locate it in this figure. So, x is 5.54, y is 4.76. So, here. So, this shall be the centroid of the entire lamina, that is g of x bar comma y bar. This is nothing but the centroidal axis xx, and this shall be the centroidal axis yy. I hope you have understood. Locate the centroid in the given figure. This completes the problem. Okay.